Right, okay. So this is the first question on limiting factors, question 97. Let's just, I think I prefer that one. I prefer that color. Okay, great stuff. So what do we have here? I'm sure you have had, oops, sorry, you've had a go at the question, and this is just to review it. So really, we're trying to see who we produce. We have one limiting factor. We have a number of products. Ultimately, we're looking for the product because it's the highest contribution per the limiting factor. So what we have to first of all find is the contribution from each product. So therefore, I must, if you like, eliminate these guys. So technically, you could just add back the 16 and this to the profit to get the contribution, as you wish. But the key point is get the contribution. So you will see that this is 46 for product A, this is 52, this is 21, and this is 60. So now I need to find out what that contribution is per the the amount of time. So 46 divided by 6, 52 divided by 8, 21 divided by 3, 60 divided by 2. Just writing my numbers here. I have 7.6 here. I have 6.5 here. I have 7 here, and I have 30 here. So just changing my pen color again, just because it means, therefore, when I rank this, I will go with this one first, then product D first, product A, product C, and then finally product B. I have 2,160 hours available. So let's see, product D, it says planned output is 400 and 2 hours per unit. So definitely product D will happen. That's 800 hours used up. Product A needs 300 times 6, that's 1,800. So product, oops, sorry, what am I doing here? 800 hours, and then you have here 1,800 hours. So just adding these two together, I can see already that I'm going to be over the 2,000. That's 2,600, isn't it? And I need 2,000. I only have 2,160 hours available. So this is what I can do. I can make A and D, but I can't make B and C. And that's question 1. So the whole point is find the highest, the one with the greatest contribution per limiting factor, and then rank them based on who's giving you the highest contribution per limiting factor. Okay, let's go to the next question. So question 99, we discussed in class the differences between slack and and shadow pricing, ultimately when you need more resource. So shadow pricing is to do with needing more resource. Slack is when you have too much of the resource, and because of the choice you've made, because it's optimal to prepare 500 units of R and 400 units of N. We are therefore in this position where we will definitely have some slack. So let's test it by simply plugging it in, and let's look at the amount of labor time available, and that would have been 3 times 500 plus 2 times 400, which is 1,500 plus 800, which is 2,300. So we can see that we're only using 2,300 with this chosen optimal point, therefore leaving 100 hours sort of idle. So the slack definitely is with labor. Let's look here with machine time. So you have 0.5 times 500, which is 250, and you have 0.4 times 400, which is 160. So adding these two together, it literally takes you to 410 hours. So this is where we would need more time. We don't have any slack with machine time. So there's only slack with labor. Okay, great stuff. So question 100. I think I'll have enough space to write it here. Really, what the issue here is that we have a limited amount of resource, and we need to sort of we almost need to sort of find out what the optimal point is, first of all, so see what's going on. So you have two products here, Q1 and Q2, and we can see that in terms of maximizing contribution, we want we would need our equation for C first of all. So we can, in terms of contribution, we can, for every unit of Q1, we have 8 pounds. I'll write 8 Q1 plus 8 pound 50 Q2. That's your contribution, sort of ISO contribution line. Let's look at the first situation. So in terms of my material, what I have here is that they give you the price, they say £2 per kilogram. You're spending £6. So you're using 3 kilograms. So you're using 3 kilograms for every Q1, if you like. So I could use all 2,000 kilograms for that Q1, right? I could, and just make Q1. Or I could also use, and if you look here, £2 and you're spending £5. So that's 2.5 Q2 is equal to 2,000 kilograms. So I could use all of that for Q2. I could do that. Now, I think what's important is I think it's a good idea to just draw the graph and maybe write Q1 here, use this as Q1 and use this as Q2, and just see what the graph would look like. If I was to use all the material for Q1, I'd be 2,000 divided by Q1, right? That means I'd make 666, right? 2,000 divided by 3 is 666. So that means I'd make 666 units of Q1, and I would make 2,000 divided by 2.5. I'd make 800 units of Q2. 800. So I'd have a graph that looked like that, right? But here's the thing. You're told, just in my pen color, you are told that you can only make 500 units of Q1. So actually, I'm stuck here for Q1 at 500. So it means that my optimal point is here, because when my ISO curve, this moves out, it will hit the corner, if you like. So that's always the case. Your furthermost point on the curve will be that corner. So really, I suppose the two lines, if I was doing an equation, where Q1 is equal to 500, and then I have this other line, which is this equation, 3Q1 plus 2.5Q is equal to 2,000. Now, but here's the thing. I have Q1. I know that Q1 is going to be 500, so I can make 500 units of Q1. So I have 3 times Q1, and that's 1,500. So I'll be using 1,500 kilograms, right? Because you can sort of visualize it. Each unit needs 3 kilograms. So if I make Q1, I'm going to make 500 units of Q1, using up 1,500 kilograms. That means there's 500 kilograms left. If there's 500 kilograms left, that means that I can make 500 divided by 2.5. So that means I can make 200 units of Q2. 200 units. So my optimal point would be to make 500 units of Q1 and 200 units of Q2. So let's see what that looks like in terms of contribution. So contribution therefore would be C is equals 8 times Q1. So that's 8 times 500 plus £8.50 times 200. And what does that mean? That gives us 8 times 500, and that's 4,000. And then £8.50 times 200, that's 1,700. So I add those two together. So my total contribution, adding these two together, becomes 5,700. Now, this question is asking about shadow pricing. So ultimately, what we're now saying is, listen, shadow pricing says if you get an additional unit or additional kilogram, because that's the material, what would be the additional contribution be? I've just found out what the contribution is as it is right now. So I'm going to give this, just give another kilogram. So that will now be 2001. So my equation is now 3Q1 plus 2.5Q2 is equal to 2001. That's my new equation. And so, as everything was, I'm still making 500 of Q1. So that's still 3 times 500. So that's 1,500. plus 2.5 Q2 is equal to 2001. So typically, really, all I'm back sort of almost saying, if I'm trying to find how many units of Q2, well, Q2 is 501 divided by 2.5. So 500, right? Because I'm going to say 2001 minus, I'm going to take 2001 minus 1500, right? Then I'll have 2.5 Q2. I mean, if I just work this out, right, I'll have 2.5 Q2 is equal to 2001 minus 1500, which means that Q2 is equal to 500 divided by 2.5. So 501 divided by 2.5 gives you 200.4. So you can make 200.4 units of Q2, technically. So that means your C now becomes 8Q1 plus 8.5 Q2. Again, of course, so 8 times 500 plus 8.5 times 200.4. So here again, of course, you will have 4,000. And when you do 8.5 times 200.4, you get 1703.4. And you add the two together, and you get 5703.4. I'll write it here, 5703.4. So the question is, what is the extra contribution as a result of buying in an extra kilogram of material? Well, the extra contribution is, well, the difference between these two, which is 3.4 per kilograms. Cool, great stuff. So we'll end that video there, and we'll carry on with the next questions in the next video.